We are going to start now lecture 10 of chapter 9 class 11th mathematics sequence and series. In this lecture we will discuss some basic facts and problems related to harmonic sequences. So first thing we have is the definition of harmonic sequence. So we are saying a sequence is said to be a harmonic progression if the reciprocal of its terms are in arithmetic progression. So we are saying that T1, T2, T3, so on, this forms a harmonic progression if 1 by T1, 1 by T2, 1 by T3, this forms an arithmetic progression. So we are talking about the sequences. This is the first example we are saying. It is 1 by 2, 1 by 5, 1 by 8, so on. This is a HP because 2, 5, 8, so on, this is an AP. Next we are saying that 2, 5 by 2, 10 by 3, this is an HP because 1 by 2, 2 by 5, 3 by 10, so on, this is an AP. Similarly, we are talking about this. We are saying A plus D, A plus 2D and so on. This is an AP. So 1 by A plus D, 1 by A plus 2D, so on. This is an harmonic progression. So we have two conditions over here. First is that no term of HP can be 0 because we are saying it is reciprocal of the reciprocal terms, they form an AP. So if the term is 0, then it is not possible over here. Second is the most general or standard HP is this. This is the most general or the standard HP that we can write. It is in this form. Next is if A, B, C are in harmonic progression, we have to prove that this result holds. So if A, B, C are in harmonic progression, it means 1 by A, 1 by B and 1 by C, these are in arithmetic progression. So this means 1 by B minus 1 by A is equal to 1 by C minus 1 by B. So if we take the LCM over here, we will get A minus B by AB is equal to B minus C by BC. B gets cancelled. So what we get is that A minus B over B minus C, that is equal to A upon C, and this is what we have proved over here. So this is A over here. Next is find the first term of the HP whose second term is 5 by 4 and third term is 1 by 2. So suppose we are saying the first term it is A. Now the HP will be A, then 5 by 4 and then 1 by 2. Then from this result we are saying A, B, C are in HP, then we have this result. So if we substitute the values over here, we get A minus 5 by 4 over 5 by 4 minus 1 by 2, that is equal to A by 1 by 2. So if we solve this, we obtain that 4A minus 5 divided by 5 minus 2 is equal to 2A. If we solve this, we get 4A minus 5 is equal to 6A, and this implies us that A is equal to minus 5 by 2. So the value of A we obtain, it is minus 5 by 2. Next is the nth term of HP from the beginning. So let A be the first term, D be the common difference of an AP. Then the nth term of this AP, it is given by the formula A plus, we are talking about AN is equal to A plus N minus 1D. This is nth term of the AP. And if we are talking about the nth term from the beginning of the HP, that will be reciprocal of this. So it is 1 by A plus N minus 1D. Similarly, we are talking about the nth term from the end. We have the nth formula for nth term from the end of the HP, that will be 1 over L minus N minus 1D. But it is being mentioned over here that there is no general formula for the sum of any number of quantities in HP, because it generally involves the inverting of the terms and making use of the corresponding AP. So there is no general term for HP we can write. So if we have any problem to find the general term, what we have to do, we have to invert the terms and we have to solve it using the formulas related to the arithmetic progression. Next question we have is, if 1 by a plus 1 by c, 1 by a plus 1 by c plus 1 by a minus b plus 1 by c minus b is equal to 0, then we have to prove that a, b, c are in HP unless b is equal to a plus c. So this thing implies us that 1 by a plus 1 by c minus b plus 1 by c plus 1 by a minus b, this is equal to 0. Now if we take LCM, we get a into c minus b, c minus b plus a, plus c into a minus b, and this is a minus b plus c, this is equal to 0. Now from both these terms we can write a plus c minus b common, and we are left with is 1 over a into c minus b plus 1 over c into a minus b, that is equal to 0. Now if we look at this term, we are talking about this part, and if we take LCM as a into c minus b, c into a minus b, in the numerator we will get c a minus c b, then it is plus a c minus a b. So this is equal to 2ac minus b times c plus a. This is the numerator, and the denominator we have this term, and this whole value is equal to 0. If we shift this denominator on this side, it will become 0. So what we obtain is that a plus c minus b into 2ac minus b into c plus a, this is equal to 0. Now we are saying if a plus c minus b, this is not equal to 0, then this term will be equal to 0. And this thing implies us that b is equal to 2ac over c plus a. So we are saying that a, b, c, we are talking about a, b, c are in HP if we are talking about this term is not equal to 0. We are saying 2ac minus b into a plus c is not equal to 0, and then the condition we are left with is that a plus c minus b is equal to 0, and this thing implies us, this condition implies us that b is equal to a plus c. So we are saying that a, b, c are in HP unless b is equal to a plus c. Now next is, if a1, a2, a3, a4 so on up to an are in harmonic progression, we have to prove that a1, a2, a2, a3, a3, a4 so on up to an minus 1 is equal to n minus 1 into a1, an. So it is being given that these terms are in harmonic progression. So this thing implies us that 1 by a1, 1 by a2 so on up to 1 by an are in AP. These terms are in AP. Now if D is the common difference, then we have 1 by a2 minus 1 by a1, that is equal to 1 by a3 minus 1 by a2, and this is equal to so on up to 1 over an minus 1 over an minus 1. Now if we take the LCM over here, we have a1, a2, this is a1 minus a2, this is equal to so on up to an minus 1 minus an over an into an minus 1, and all these values, these are equal to D, the common difference. We are saying common difference is equal to this value. So from this we can calculate a1, a2 is equal to a1 minus a2 by D. Similarly we will have an minus 1, this is equal to an minus 1 minus an over D. Now if we substitute these values in this equation, we are considering the left hand side of this equation, and we substitute these values, we write 1 by D common, and we are left with is a1 minus a2 plus a2 minus a3 so on up to plus an minus 1 minus an. So this a2 gets cancelled, a3 gets cancelled, this an minus 1 get cancelled, and we are left with is 1 by D into a1 minus an. Now this term we can write, it is 1 by D into, if we multiply and divide this result by A1 AN, we are saying we are multiplying it with A1 AN and dividing it by A1 minus AN over A1 AN. So this is equal to A1 AN divided by D into 1 by AN minus 1 by A1. These terms are in arithmetic progression. These terms we are talking about. So the value of AN from this we can write. The value of 1 by AN is equal to first term plus N minus 1 D. So we can substitute this value over here. So we are writing this is equal to A1 AN divided by D into 1 by A1 plus N minus 1 D minus 1 by A1. This gets cancelled, D gets cancelled, and we are left with this A1 AN into N minus 1, and this is the result that we have to prove. This is the final result that we have to prove. Next is the sum of three numbers in HP is 37 and sum of their reciprocals is 1 by 4. So we are considering the three numbers in HP. They are 1 by A, 1 by A minus D and 1 by A plus D. Their sum 1 by A minus D plus 1 by A plus 1 by A plus D, this is given to be 37. We are saying their sum of their reciprocals, it is A minus D plus A plus D is given to be 1 by 4. This D gets cancelled, we get the value of A is 1 by 12. So if we substitute this value in this equation, we will obtain 1 over, in place of A we are writing it is 12, so it is 12 over 1 minus 12D plus 12 plus 12 over 1 plus 12D, that is equal to 37. So what we obtain is, if we write 12, this 12 we shift on this side, we write 12 common, we are left with is 1 minus 12D plus 1 by 1 plus 12D, that is equal to, this value we have it is 25. And on solving this result we obtain, this is implies us that 12 into 1 plus 12D plus 1 minus 12D divided by 1 minus 144D square, that is equal to 25. These two values gets cancelled. So this implies us that 24 by 1 minus 144D square is equal to 25. So from this what we obtain is that 1 minus 144D square, that is equal to 24 by 25. This implies us that 1 minus 24 by 25 is equal to 144D square. Now this value comes out to be 1 by 25, and this implies us that if we take the square root over here, we get 1 by 5 into 12 is equal to, plus minus of this is equal to D. So this implies us the value of D is plus minus 1 by 60. Now we have the value of A. The value of A we have it is equal to 12. The value of D we have it is plus minus 60. So if we substitute both these values in this, what we have assumed, we obtain that the numbers that are in AP, we are calculating the value of A plus D, that will be, we are talking about A minus D, A and A plus D. So the value of A we have it is 1 by 12. Value of A plus D and A minus D, they will be same in this case, and the answers we have it is 15, 1 by 15 and 1 by 10. So the numbers in HP we have, they are 15, 12, 10 or 10, 12 and 15. So these are the numbers, required numbers which are in harmonic progression. Next is, if the pth, qth and rth term of AHP be respectively A, B and C, then prove that this result holds. So we are saying 1 by A will be the pth term of the AP, 1 by b will be the qth term and 1 by c will be the rth term. So if we substitute these values over here, we are considering the first term is a plus p minus 1 d. This is a plus q minus 1 d, and this is a plus r minus 1 d. Now if we subtract equation 2 and 3, we are subtracting equation 2 and 3, we obtain 1 by b minus 1 by c, that is equal to q minus r into d. If we take LCM over here, we get it is, if we write LCM, c minus b over bc, that is equal to q minus r into d. So from this result, we are getting the value of q minus r, that is equal to c minus b divided by bc d. Or if we look at what we have to prove, it is q minus r into bc we have to solve. So we shift this bc on this side. So we are having the value of bc into q minus r, that is equal to c minus b over d. Now similarly, we will have r minus p into ca, and we can calculate the value of p minus q into ab. So if we add all these values, we will have 1 by d will be common, and what we are left with is c minus b, then plus a minus c, then plus b minus a. Now from these terms, this a gets cancelled, b gets cancelled, and c gets cancelled, and the final answer we obtain it is 0, and this is what we have to prove. Next we have is, if a, b, c are 3 consecutive terms of a series, then we have the conditions. First is, if a minus b over b minus c is equal to a by a, that is equal to 1, then we are saying that these numbers, they are in AP. This thing is clear. We are saying it is a minus b is equal to b minus c. So these numbers, these are in AP. Second condition we are saying is, if a minus b over b minus c is equal to a by b. If you multiply these terms, this will implies ab minus b square is equal to ab minus ac. AB gets cancelled, we get b square is equal to AC. It means these 3 numbers, they form a GP. And third condition we have is, if a minus b over b minus c is equal to a by c, then they form an HP. This result we have already proved in our previous slide. So this is the condition on the 3 numbers to be in AP, GP and HP. So we have to calculate the value of a minus b over b minus c. So depending upon the value, we can tell whether these numbers, these are in AP, GP or HP. Now next we have is, if a, b, c are in arithmetic progression and a square, b square, c square are in harmonic progression, then we have to prove that minus a by 2, b, c are in GP, or else a is equal to b is equal to c. It is a constant sequence. So first condition we have is that a, b, c are in AP. So this thing implies us that b is equal to a plus c by 2. Next, second thing that is given to us is that a square, b square, c square are in HP. So from this we obtain that b square is equal to 2a square c square by a square plus c square. Now from both these equations, what we obtain is, suppose first we are considering the second equation. So what we obtain is that b square into a square plus c square, that is equal to 2a square c square. Now if we look at this term, it is b square into this value we have a square plus c square, we can write it as a plus c whole square minus 2ac, that is equal to 2a square c square. The value of a plus c we have, it is 2 times b. We are talking about this value. If we substitute this value over here, we get b square into this value, it is 4b square we have the value, it is 2b. Then it is minus 2ac, that is equal to 2a square c square. So if we take 2 common, this 2 gets cancelled, 2 gets cancelled, 2 gets cancelled, and we get 2b raised to the power 4 minus acb square is equal to a square c square. So this gives us the equation 2b raised to the power 4 minus acb square minus a square c square is equal to 0. And if we factorize these terms, we obtain 2b square plus ac into b square minus ac is equal to 0. So this implies us, now this thing implies us that 2b square plus ac is 0 or b square minus ac is 0. Now we have two conditions. The first condition we are saying, when 2b square plus ac is 0, then we have b square is equal to minus 1 by 2 ac. So this implies us that minus 1 by 2a, we are considering one term, we are saying minus 1 by 2a, c and b are in GP. From the second condition we have b square is equal to ac, and this implies us that a, b, c are in GP. Now we have two conditions, one is a, b, c are in GP, and second it is given that a, b, c are in AP, and we have already proved that three numbers are both in AP and GP. This thing implies us that it is a constant sequence, that is a is equal to b is equal to c. So we are having these two results. First is that either we have minus a by 2 b c are in GP, or we have a is equal to b is equal to c, that is it is a constant sequence. Now next is, if a, b, c are in harmonic progression, a, b, c are in HP, b, c, d are in GP, c, d, e are in AP, we have to show that E is equal to a b square by 2a minus b whole square. So first thing that is given to us is that a, b, c are in HP. So this thing implies us that b is equal to 2ac by a plus c, or we can write c is equal to a b by 2a minus b. Second thing that is given to us is that b, c, d are in GP. So b, c, d are in GP means c square is equal to b into d. And third thing that is given to us is that c, d, e, these three numbers they are in AP. So we have d is equal to c plus e by 2. So this implies us that the value of e we have, it is 2d minus c. Now if we substitute the values of d, d from this equation over here, we obtain, this implies us e is equal to 2c square by b minus c. And if we substitute the value of c from the first equation, this thing implies us e is equal to 2 by b into a b by 2a minus b whole square minus a b by 2a minus b. We have substituted these values. So if we take the LCM over here, we are writing it is a b by 2a minus b whole square we have taken common. In the first bracket we are left with is 2 by b, a b by, this term we have already taken common. From the second term we are left with is 2a minus b. So this b gets cancelled, and the answer we obtain, it is a b by 2a minus b whole square into, over here we have the term 2a minus 2a, and this is b. So this b becomes b square, and this is the required value. It is a b square by 2a minus b whole square. This is the required value over here. Now next we have is if A, B, C, D, E be 5 real numbers such that A, B, C are in AP. So if A, B, C are in AP, it means B is equal to A plus C by 2. Next it is given that B, C, D are in GP. So if these are in GP, we have C square is equal to B into D. And third thing that is given to us is that C, D, E are in HP. If these three are in HP, we have D is equal to 2CE divided by C plus E. Now the values of A and E are given to be 2 and 18. We have to find all possible values of B, C and D. So if we look at these conditions over here, we can substitute the value of B and D from these equations over here. So what we will obtain is that C square is equal to A plus C by 2 into 2CE divided by C plus E. This 2 gets cancelled. And if we cross multiply these terms, we will get C square into C plus E, that is equal to CE into A plus C. Now the value of C, if we consider it is not equal to 0, then this C gets cancelled. Why we are saying it is not 0? Because B, C, D are in GP and C, D, E are in HP. So it means the value of C cannot be 0. So one of these C gets cancelled. So what we obtain from this is that C square plus CE is equal to AE plus EC. EC gets cancelled. We are left with this C square is equal to A into E. So if we substitute the value of A and E in this equation, this implies us C square is equal to 2 into 18, that is equal to 36. So this gives us C is equal to plus minus 6. We obtain the value of C is equal to plus minus 6. Now if we substitute these values of C in this equation, we obtain the value of B is equal to 2 plus minus 6 by 2. So two values we are obtaining, it is 4 and minus 2. And next we are talking about the value of D. From this equation, we are having D is equal to C square by B. Now C square is 36 by B is either 4 or minus 2. So if we substitute these values over here, we will obtain two answers. It is either 9 or minus 18. So we are saying that the possible values are C is equal to 6, B is equal to 4, D is equal to 9. And the second set we will have it is C is equal to minus 6, B is equal to minus 2 and D is equal to minus 18. So these are all possible values of B, C and D. Now next is harmonic mean. So we are saying if three numbers are in HP, then the middle term is called the harmonic mean between the other two. So we are saying if A, B, C are in HP, then B is harmonic mean between A and C. So the first case we have is single harmonic mean of n positive numbers. So suppose we are given the numbers, it is A1, A2, A3 so on up to A1, A1, A2 so on up to AN. Then the harmonic mean between these numbers H is equal to n over 1 by A1 plus 1 by A2 so on up to plus 1 by AN. So this is the formula for the harmonic mean between these numbers. Next is if A and B are two given numbers, then the harmonic mean between them it is given by harmonic mean between two numbers A and B, we have it is 2 by 1 by A plus 1 by B. So answer we get it is 2AB by A plus B. So this is the harmonic mean between two numbers. Similarly, if three numbers A, B, C are given, then the harmonic mean it is given by A, B, C by AB plus BC plus CA. So an important point to note over here, it is that if arithmetic mean between two numbers A and B is A plus B by 2, then it does not follow that the harmonic mean is 2 by AB. It is 2AB by A plus B. The next we have is to insert the n harmonic mean between two numbers. So we are saying suppose A and B, these are two numbers and we are inserting n harmonic mean between them. We are talking about the harmonic means h1, h2, so on up to hn. We have inserted n harmonic mean between these numbers. Then clearly we have all these numbers, they form an HP, and the corresponding AP that we will have, corresponding to this, the AP we will have, it is 1 by A, 1 by H1, 1 by H2, so on up to 1 by Hn and 1 by B. This is the AP corresponding to this HP, and let the common difference over here, it is D. Now clearly we have this B, this is the n plus 2th term of HP. So we are saying the value of B we will have, that will be, the value of B we are saying that will be 1 by A plus n plus 2 minus 1 into D. Look at these conditions over here. This is the value of 1 by B, or we are writing the value of B, so it is 1 by this term. So this implies us, this thing implies us that 1 by B is equal to 1 by A plus n minus n plus 1 into D, and this implies us that the value of D we have, it is 1 by B minus 1 by A divided by n plus 1. So this is the value of D that we have. It is 1 by B minus 1 by A over n plus 1. So what we obtain is, from these results, what we obtain is that the value of 1 by H1 is equal to 1 by A plus D, 1 by H2 is equal to 1 by A plus 2D, and so on. 1 by Hn is equal to 1 by A plus n D. And if we substitute this value of D in these formulas, we will obtain the final results in the form that 1 by H1 is equal to 1 by A plus A minus B over AB plus n minus 1 into n minus 1. 1 by H2 is this value, and last 1 by Hn is equal to 1 by A plus n into A minus B over AB into n plus 1. So these are the n harmonic means between these two numbers A and B. Now next result we have to prove is that the sum of reciprocals of n harmonic mean between two given numbers is n times the reciprocal of the single harmonic mean between them. So we are saying two numbers A and B, these are given. We have inserted n harmonic means, it is H1, H2, so on up to Hn. We have inserted these n harmonic mean between them. Then we are saying that this whole sequence, this forms an harmonic progression. We are talking about the value of 1 by H1 plus 1 by H2, so on up to plus 1 by Hn. So we are saying that 1 by H1, 1 by H2, so on up to 1 by Hn, this forms an AP, and the number of terms we have, it is n, and sum of this AP is equal to n by 2 into first term plus last term. So we are saying this is equal to n by 2 into 1 by H1 plus 1 by H2. Now we have the value of 1 by H1. When we are talking about the value of 1 by H1, we have this term 1 by A over here. If the common difference is D, then this value is n by 2 into A, 1 by A plus D. And if the last term we have over here, it is 1 by B and the common difference is D, then we are writing it is 1 by B minus D. So the answer we have, it is n by 2 into 1 by A plus 1 by B. And this thing we can write, this is n over 2 over 1 by A plus 1 by B, and this is, we can write, this term we can write, it is n over harmonic mean between A and B. And this is what we have to prove, that the sum of reciprocal of n harmonic means, the sum of reciprocal of n harmonic means, that is equal to the n times the reciprocal of single harmonic mean between them. This is n by harmonic mean between A and B. Next is, if h be the harmonic mean between x and y, we have to prove this result. So if h is the harmonic mean between x and y, so we are writing h is equal to 2xy over x plus y. Now we have to prove this result. It means we have to calculate the value of h plus x over h minus x, h plus y over h minus y. So we can write this is equal to, from this we are saying, this implies us that h by x, that is equal to 2y over x plus y, and if we write the value of h by y, that is equal to 2x over x plus y. Now if we apply componendo dividendo to both of these, we get h plus x over h minus x, that is equal to, these values will be added, we will get x plus 3y over y minus x, and h plus y over h minus y, that is equal to 3x plus y over x minus y. Now if we add both these values, we will get h plus x over h minus x plus h plus y over h minus y, that is equal to x plus 3y over y minus x minus 3x plus y over y minus x, and this is equal to, we can write y minus x common, we are left with is x plus 3y minus 3x minus y. Now both these terms gets cancelled and we are left with is 2, and this is what we have to prove, that this sum of these two values, it is 2. Now next we have is, if a1, a2, a3 so on up to a10, these are the terms in AP, and h1, h2, h3 so on up to h10, these are the terms in harmonic progression. If a1 is equal to h1 is equal to 2, a10 is equal to h10 is equal to 3, then find the value of a4h7. Now it is being given that the value of a1 we have it is 2, then we have terms over here, and the value of a10 we have it is 3. Value of h1 we have 2, so on up to the value of h10 we have it is 3. These terms are in AP. So the common difference d that we have over here, it is a10 minus a1 divided by 9. So that comes out to be 1 by 9. So what we obtain from this is that the value of a4 is a1 plus 3 times d. So that is equal to 2 plus 1 by 9, 1 by 3. Answer we get it is 7 by 3. This is the value of a4 that we have. Now next we have these terms, they form an harmonic progression. So we are saying that we have an AP 1 by 2 so on up to 1 by 3, and the common difference of this AP, it is given by 1 by 3 minus 1 by 2 divided by 9, and the answer we obtain, that is equal to minus 1 by 54. Now to calculate the value of h7, we are using 1 by h7, that is equal to 1 by h1 plus 6d. So answer we get it is 1 by 2 minus 6 by 54, that is equal to 7 by 18. So this implies us that the value of h7 we have it is 18 by 7. This is the value of h7 that we have. Now we have to calculate the value of a4 into h7. So that is equal to, the value of a4 we have it is 7 by 3 into h7 is 18 by 7. The answer we obtain, it is equal to 6. So this is the value, required value of a4 into h7. Now next is find the value of n, so that this value is a harmonic mean between a and b. So it is being given that a raised to the power n plus 1 plus b raised to the power n plus 1 over a raised to the power n plus b raised to the power n, this is equal to 2ab divided by a plus b. This is the harmonic mean between a and b. So if we divide the numerator and denominator by b raised to the power n over here, we will obtain a by b raised to the power n plus 1 divided by a by b raised to the power n plus 1. The numerator From numerator we have taken b raised to the power n plus 1 common. From denominator we have taken b raised to the power n common, and it is equal to, over here we can write it is b square into 2a by b divided by b into a by b plus 1. So this thing implies us, this b gets cancelled over here, this b if we shift on this side, this will become n plus 1, this b n plus 1 gets cancelled. We are left with this a by b raised to the power n plus 1 divided by a by b raised to the power n plus 1 is equal to 2 times a by b divided by a by b plus 1. Now if we substitute this a by b as say t, so our equation becomes t raised to the power n plus 1 divided by t raised to the power n plus 1 is equal to 2t over t plus 1. So if we cross multiply these terms, we will obtain t raised to the power n plus 1 into t plus 1, that is equal to 2t into t raised to the power n plus 1. So if we multiply these terms, this implies us t raised to the power n plus 2 plus t raised to the power n plus 1 plus t plus 1 is equal to 2t raised to the power n plus 1 plus 2t, and this implies us that t raised to the power n plus 2 minus t raised to the power n plus 1 minus t plus 1 is equal to 0. So if we factorize these terms, we are writing it is t raised to the power n plus 1 into t minus 1 minus t minus 1 is equal to 0. So this implies us t raised to the power n plus 1 minus 1 into t minus 1 is equal to 0. So we have two values of t over here. One is that t raised to the power n plus 1 is 1 or t is equal to 1. Now if we substitute t is equal to 1, we will obtain, this implies us that a is equal to b. Then there is no meaning of asking this thing, it is already being given that a is not equal to b. So we are saying that t is equal to 1 is not the possible value over here. So what we are left with is that t raised to the power n plus 1 is equal to 1. So this implies us that the value of n we have, that is equal to minus 1. So we are saying the value of n in this case, it is minus 1. Next is insert 6 harmonic means between 3 and 6 by 23. So we are saying that we have the numbers, it is 3 and 6 by 23, and we have to insert 6 harmonic means between them. It is h1, h2, h3, h4, h5 and h6. We have to insert 6 harmonic means. So this sequence, this is in HP. So we are saying 1 by 3, 1 by h1, 1 by h2, 1 by h3, 1 by h4, 1 by h5, 1 by h6 and 23 by 6. This is an AP. So if we calculate the value of D over here, we are saying the value of D will be equal to, the first term we have over here, it is 1 by 3, last term is this. So it is 1 by 7 into 23 by 6 minus 1 by 3. And the answer on solving this we will obtain, these calculations are shown over here, the answer we obtain it is 1 by 2. So we are saying the value of 1 by h1, that is equal to 1 by 3 plus 1 by 2, that is equal to 5 by 6. So this implies us h1 is equal to 6 by 5. The second value we are saying it is h2 is equal to 6 by 5, or we are saying it is 1 by 3 plus 2 times d, it is 1. So this is equal to 4 by 3. So this implies us, this is the value of 1 by h2. So the value of h2 is 3 by 4. Similarly 1 by h3 is equal to 11 by 6, which implies us h3 is equal to 6 by 11. Next is 1 by h4 is equal to 1 by 3 plus 4 into 1 by 2. Answer we obtain it is 7 by 3. So this implies us h4 is equal to 3 by 7. and the value of 1 by h5 is equal to 1 by 3 plus 5 by 2, that is equal to 17 by 6. So this implies us h5 is equal to 6 by 17, and last we are saying it is h6 is equal to 1 by h6 is equal to 1 by 3 plus 3, this is equal to 10 by 3. So this implies us h6 is equal to 3 by 10. So the numbers, the harmonic mean, the 6 harmonic mean between these two numbers, they are given by 1 whole 1 by 5, 6 by 5, then 3 by 4, 6 by 11, 3 by 7, 6 by 17 and 3 by 10. So these are the 6 harmonic mean between 3 and 6 by 23.